Welcome to a simple introduction to using graph algorithms with TigerGraph. For the purpose of this tutorial, I have designed a very simple graph model based on one-day statistics of Indian cricket player Sachin Tendulkar. Now let's go and see how the data looks like. This is a CSV file that contains the various columns of one-day matches played by Sachin. The first column is the match ID, which is just a sequence number, and the second column represents the runs scored in every match. I also have the position at which he batted, have the type of the dismissal, and whether in this particular match the Indian team played first or second, against which opposition the match was played, and when the match was played. In order to build better relationships across these records, I have added two more columns called previous match ID and the previous match ID against the same opposition. The previous match ID gives the match ID, the previous match ID for every match. For example, for match ID 2, the previous match ID is 1. For match ID 3, the previous match ID is 2. For match ID 4, the previous match ID is 3. The previous match ID SO represents the previous match ID against the same opposition. For example, if you take match number 10, he played it against Sri Lanka, and when he played Sri Lanka before this particular match, and it was the match ID 8. So in row number 10, I have the match ID 8 for the column previous match ID against the same opposition. Now let's go and see how the graph model looks like. I look at the design schema. So I have the match ID node, I have the opposition, I have the batting position, I have the run score, I have the innings, I have the dismissal, I have the balls faced. And not only that, the previous match ID is a self-referencing relationship. That is, the match ID is associated with another match ID. And that's the same case with previous match ID against the same opposition also. Once I have designed the model, I have mapped the data from the source files to the various vertexes and the edges. Now I have picked up the dishing values of the opposition, loaded into opposition, same case with batting position, same case with runs, same case with innings, same case with dismissal, and same case with balls. Loaded the match ID into the match ID column and also use the Sachin.csv file to load the previous match ID and previous match ID against the same opposition. Once I have done the data mapping, I can go ahead and load the data. And this is how the loaded data looks like. Once I ran the job, this is the total number of vertex and edges I have. Now I can go ahead and see, before we look at the individual graph algorithms, let us go ahead and use the functionality Explore Graph. I click on the Explore Graph, and you see there are plenty of options on the left-hand side. Expand from vertices, find the paths, find connections, and run queries. I choose the find paths option. Here I have the vertex type. I choose the match ID. And here also, right, I choose the, click on the find paths, choose the match ID. I type the vertex ID 1, the first match. Here also I choose the match ID. I choose the last match, which is this. If I come back here, I have 295. Show one shortest path is the option I have selected. So I click on the find path. Now this is what I get. Match number 1 and match number 295. The shortest path is the mode of dismissal. In both the matches, he was dismissed by the dismissal mode card. Let me go undo this and I choose show all shortest path. Now this could bound to take a little more than choosing only the shortest path. But still let's go ahead and do it and see how it looks like. I click on the find path. Now I can go and explore the various layouts. So this view presents a better view between the first match ID and the last match ID 284. Now let's go ahead and choose some other method of exploring. I choose the opposition here and I choose the opposition here too. And I choose Pakistan. I tap Australia, the other opposition. And let me do undo. I choose show one shortest path. Now if you see, this is a connection between the Pakistan and Australia. The match number 290 was played against Pakistan and 289 was played against Australia. So that's the connection between the two oppositions. So I can choose show all shortest paths and click on find paths. Now I get a better view. Okay. So I can choose show all paths also. Okay. So let me go and do undo here. And I choose show all paths and click on find paths. This is going to take a while mainly because we have more number of nodes now. So actually, now if you see actually, this has become clumsy mainly because right one way or the other, right, all the nodes are connected with all other nodes. So node ID 2 is connected with 1, 3 is connected with 2, 4 is connected with 3. So you have every path coming. But even though you have every path coming, still right now we are able to get all the paths very, very fast. So let us just go and restrict ourselves to show all shortest paths. And then now this is what we get here. Okay. Now there are plenty of graph algorithms provided by TigerGraph. You can see the list of algorithms here. Centrality algorithms, classification, community, node embedding, path finding, similarity, and topological link prediction algorithms. We will explore these algorithms one by one with this simple graph model. Thank you. The code of this particular model can be found in GitHub and the link is provided along with this particular video.